Morning students. So today we are going to discuss IIT-JEE NEET Foundation. The topic work, power, energy. Work is work, power, energy. These are important topics in the mechanics. Work, whenever force acts in a body, body displaces in the direction of the force. Power, the capacity, the rate of work done. What we will call it as a power. The rate of work done is called power. Energy, the capacity to do work is called energy. So these topics we are going to discuss today's class. See, first there are topics to be covered are work done by the constant force and positive work, negative work. See, there is some difference in the normal work and the definition of the physics work. In the case of normal work, whenever you do some work like sleeping or running, all these things we are taking it as a work or something. Okay, so we are doing something, so taking out some objects or so daily work, going to, there are the attending offices, all this we will call it as in the daily life we will call it as a work. But in the physics, the definition of the work depends upon the force, displacement and angle between the force and displacement. So this is the main difference you should understand. So the work is said to be whenever force acts on a body, body displaces in the direction of the force. See the topics here, the work, basically this is the simple mind map of the work. Work depends upon force and displacement. Work done by the constant force. Work done by the constant force is nothing but W equal to Fx. W equal to Fx. See this formula, force into displacement. If the force and displacement are acts in same direction, or the angle between force and displacement are 0 degrees. So force Fx, W equal to Fx, or if the force is having or displacement, force and displacement are making some inclination, some angle of inclination. So that angle of inclination, between the force and displacement is also matters here. That angle of inclination are, okay, whatever this theta is the angle of inclination. So force and displacement, see force and displacement, let us take this is the force and this is the displacement, the angle between force and displacement. So W equal to Fs cos theta or Fx cos theta. W equal to Fx cos theta, or you can take it as S also. So here S or X are displacement. So next one is if there is a variable force is there. Variable force varies with okay, so displacement or etc. So there certain cases the force is not constant. When force is not constant, the integral of f dx, you have to write fx dx. Actually fx is nothing but f cos theta. Fx is nothing but f cos theta dx. So these are the work formulas. Work done by the constant force is Fx cos theta. Work done by the variable force is integral of Fx. Okay, so Fx dx you can write, or f cos theta dx you can write. So this is about the work formulas. And work always there is connected with the force. Work always, see there is force you are acting, the force, whenever the force acts on the body displaces, and the displacement is, let us say, d. So when the body is applied by the force, when the force is applied on a body, the body displaces in the direction of the force. So that we will call it as a work done. Here work is done, the force acts in the direction of the motion. The force acts in the direction of the motion. See here there is a force is acting, but here the force is parallel to the surface. That's why angle between the force and displacement is 0 here. But in this case the force is inclined force, something like there is certain inclination with certain angle, the force is acting on the object. So due to the force, inclined force, there is a body displaces in the horizontal direction. So that angle of inclination is also matters. Here also we will call it as a work done. Work is done when force acts on a body. So that may be an inclined force or parallel force. So but it displaces in the direction of the force. So that we will call it as a work. But the middle case, if you observe, there is no work done. You are applying a force on the body. So due to the application of the force, the body does not have any position change. There is no change in the position. So that is called no work done. So zero work done. Work is, see, according to physics, so when force acts on a body, body should displace in the direction of the force. If there is no work, so if there is no displacement, if there is no force, or so either displacement or force are not there, then the work done will be zero according to physics. Work done will be zero. So here force is there, object is there, you are acting a force on the object, but body do not have any change in its position. So that is called as no work done, zero work done. So body has no motion. When there is no motion, there is no work done. So similarly, here another case, you are acting a force, but this force is perpendicular to the displacement. The force is perpendicular to the displacement. Fx cos theta, theta value is 90 degrees, cos 90 is 0. That's why cos 90 is 0. So the work done will be 0. When force acts perpendicular to the direction of the motion, that also we will call it as a no work done. The middle case, all these are no work done. Here there is a work done, but okay, so the parallel force displacement work done will be there, and work done formulas. All these things are just a mind map to understand the, see, work, see the amount of force which is act on a body, body displaces in the direction of the force. See, coming to the next one, see, power. Power is nothing but the rate of work done. The rate of work done is called power. Power, usually horsepower, we come across, there is HP, 1 HP motor, 2 HP motor, etc. See, these are called power. There is some work or energy. There is some work or energy in a particular time. That work done per unit time is called power. So this power having many applications like mechanical applications, electrical applications. We come across a lot of different applications in our daily life. That is power. Electrical appliances, heat applications, there is heat energy normally. Okay, so you take any electrical appliance, there is some power will be mentioned. It is a 1 watt or 2 watt, 3 watts, etc. So similarly, heat applications, electrical heaters. So you will observe there is a how much power which is going to be consumed, all those things. So these are all called as power, and the rate of work done is called power. The rate of work done is called power. The rate of utilization of energy is also called power. The rate of utilization of energy. So power is directly depends upon the energy or work. You can understand. Okay, so energy or work. So here since it must be as the amount of energy only. Power, when you say power, there is certain time, certain energy is utilized. There is certain work, certain time. So there is work done. The rate of work done, rate of energy utilized is called power. And power is also another angle, that is there is a sound intensity. There is a power. The intensity is nothing but the power which is utilized through the area of cross section. That only we will call intensity. And power is there in the light also. There is a power of the concave lens, power of the the reciprocal of focal length, all those things which is comes under the, so we are calling as a power in the case of the light. Electromagnetic waves also there is a power. So power of electromagnetic wave means the rate of energy which is utilized through the unit area of cross section. So all these things are interconnected. Power is something in the physics, it is a interconnected topic for all the chapters like heat, electricity, sound, light, all chapters everywhere we will observe the power. See, power concepts are very, very important in the physics. See, you should understand power very clearly. You should not get confused with work, power. Work is something, the force and displacement, and power is the rate of work done. Work per unit time is called power. Coming to the next topic, that is energy. See, energy is nothing but it's a very important in the definition of the physics itself. Physics is a branch of natural science which deals with the bodies. So there is something like matter and energy. Matter and energy, their mutual interactions. That only we will call physics. Energy is a vital role in the physics. So that energy is nothing but, so the capacity to do work is called energy. The capacity to do work is called energy. Or so there is some law of conservation of energy. Energy neither created nor destroyed. It transforms one form of energy to another form. Different forms are there in energy. That only you are explaining here. So energy and a related mind map. That is something like, see, multiple forms of energy. So energy examples, many examples will be there for energy. Kinetic energy, potential energy, so electrical energy, sound energy, so many different, okay, so electrostatic energy, gravitational potential energy, so elastic potential energy. So these are all different examples we can. And conservation of energy, it is also very important. Utilization of 100% energy. For example, sun is radiating, that sun energy which is converted into some, by photosynthesis process, carbohydrates are generating in the trees. That carbohydrates, again it will be converted into coal or something like we are taking, we are having some, when you take some leaves or something, so are some animals which are going to eat that carbohydrates, and animals gets, okay, so their energy, muscular energy or some, see, the forms of energy. Energy neither created nor destroyed. It transforms one form to another form. Energy remains constant. Energy disappears in one form, then reappears in another form. Energy is always remains constant. That comes under the law of conservation of energy. And next important theory, that is work energy theory. The work energy, so the entire work is converted into energy, or change of kinetic energy is equal to the work done. Change of kinetic energy is equal to work done. See, that is comes under work energy. See, basically the capacity to do work is called energy. Here the energy forms like kinetic energy, potential energy. Kinetic energy, the energy possessed by virtue of its motion. The energy possessed by virtue of its motion called kinetic energy. The energy possessed by virtue of its position or state, we will call it as a configuration. What we will call it as a potential energy. In the potential energy, gravitational potential energy, electrostatic potential energy. So these are the things we will discuss. Okay, so in the case of energies, energy is also vital. It's a very important term in the physics. Like work is important, power is important, and energy is also important. Work, power, energy. The topic is work, power, energy. So in this actually continuation, see, work is having some specific definition related to the application of the forces and displacement. Whenever force acts on a body, body displaces in the direction of the force. That is called work. The multiplied by the, see here, the physics work is defined as product of force. The product of force and applied on the object and a distance covered, distance over which the force acts multiplied by the cosine angle between the force and displacement. It means that work is equal to Fs cos theta. Work is equal to Fx cos theta. That you have to understand here. Force into displacement is cos theta. So work is measured in joules. Work units are joules. Work is equal to, so force into displacement. Work is equal to force into displacement. Force units are newtons, displacement units are meter. Newton meter is called joule. Newton meter is called joule. Newton also can be written as, Newton is nothing but force, kg meter per second square. It means kg meter square per second square. kg meter square per second square you can write. And another unit, this is the SI unit, joule is the SI unit, MKS unit is so kg meter square per second square. Another unit of work is that is CGS erg. Erg is the CGS unit. One erg is nothing but see dyne centimeter you can write, because in CGS the unit of force is dynes, the unit of displacement is centimeter, dyne centimeter. So 1 dyne centimeter is nothing but gram centimeter square per second square. You can write in terms of CGS also like this. So the dimensional formula of the force, the dimensional formula of the work is nothing but, so by using kg meter square per second square, you can write kg is m power 1, meter square is L power 2, so time is T power minus 2. M power 1, L power 2, T power minus 2. This is the dimensional formula of the work. See, work depends upon the force and displacement, the angle between force and displacement. This is important thing. So, and next one is whenever force acts on a body, the angle of inclination to calculate the work done, FD cos theta. The similar formula we have to use it. In this formula, the cosine angle is very important. What angle? The angle between the force and displacement is 0 degrees. See, that is only explained here. The force and displacement, if it is 0 degrees. So that is so both are in same direction. If both are in same direction, so force and displacement are in same direction. The vectors, since force and displacement are vectors, that's why work is a scalar product between force and displacement. It's a dot product between force and displacement. Dot product between force and displacement. So here the angle theta is 0 degrees. See, cos 0 is 1, the work done is equal to Fs. The magnitude of the force contributes the work done. Here, the force and displacement are perpendicular each other. So it means that theta is the 90 degrees. Theta is 90 degrees, then work done will be 0. The work done will be 0 because force and displacement are perpendicular each other. So the angle is 90, cos 90 will be 0, work done will be 0. So that is another no work done. Here no component of force which can displaces the direction, displaces of a body. So next one, if the force and displacement are making an angle of 180 degrees, if the angle between the force and displacement is 180 degrees, so then work done will be, see, cos 180 is minus 1. See, cos 180 minus 1, that's why work done will be negative work done. That work done, what we will call it as a negative. Work done is equal to minus Fs minus Fx you are going to get. So these are some important points in the work. See, coming to the next here, when the force does no work, when the force does no work, so here force is perpendicular to the motion, that's why it is called no work. Force is perpendicular to the motion, that's why it is called no work. See, if you observe here, see, the force is perpendicular to the motion, no work done. When object is carried by the constant velocity which acts on the right angle to the motion, no work done. And here the force is parallel. So but even though the body has no displacement, you are applying a force but body is not moving because it is a bigger object. The object is bigger, you are acting some force on it, but even though body has no displacement, so hence there is no work done. In this case also no work done. Work, see, when a force does no work, see, it does sometimes no work also. Always force may not do the work in the physics. So that is most important. The body should move, the body should change its position. Then only we will call it as a work. Otherwise we cannot call it as a work. See, that is one important thing we have to remember. And the next one, see, positive work and negative work. These are the two important things. Positive work is nothing but when the angle between the force and displacement is from, so something like the positive work, the angle between the force and displacement is 0 to 90 degrees. 0 to 90 degrees. So it means that cos 0 is 1. Cos 0 is 1. Cos 30 root 3 by 2. Cos 60. So 1 by 2. So cos 90 is 0. Cos 90 is 0. So 1 to 0, the values which gives the positive work done, the angle between the force and displacement is 0 to 90 degrees. Then the work is said to be, see, the resulting a positive work. The positive work, what we will call. So negative work is the examples of positive work. If you take the examples of positive work, like a lifting an object. So when you lift the object vertically against the gravity, so the force are in the same direction of the displacement, hence it is called positive work done. Or pushing a cart, so the force is applied on the cart moves in the direction of the force, the angle is something like 0 to 90, so then it is called positive work done. Stretching a spring, if you are stretching a spring, so the force and displacement are in same direction, that's why it is also a positive work done. So this is about positive work done. Negative work done is nothing but the angle between force and displacement is 90 to 180 degrees. The angle between force and displacement is 90 to 180 degrees. That is called, so, negative work done. Negative work done is, see, why? Because cos 90 is 0, cos 180 is minus 1. So the value of cos here 0 to minus 1. So it is changing. Cos 90 or cos 120 you take. Cos 120, cos 180 minus 60. So cos 120 is the second coordinate, cos is negative, minus cos 60, minus 1 by 2. Cos, similarly 150, minus root 3 by 2. That's why all are negative. Cos values are negative, hence the work done is also negative. So these are the negative work done. The angle between force and displacement is 90 to 180 degrees, negative work done. In the case of negative work done, if you observe the examples, lowering the object. When you lowering the object, the force is acting in one direction. See, when you lower the object against the gravity, force and displacement are opposite in direction, then negative work done. Or similarly, when car is moving, so with certain velocity or acceleration, so whenever the applied braking force, negative work done, it is also, see, braking of a moving vehicle, it is also negative work done. It leads to the negative because it is against the motion. Next one is compressing a spring. In the earlier case, positive work done, stretching a spring. Here, negative work done, compressing a spring. When spring is compressed, it is a negative work done again. So these are all the different examples of the positive work done and negative work done. I hope you understand. So thank you very much. Thanks for watching this video.